What?
Yeah.
I mentioned this pose at the lunch room yesterday. I just said. No, but I mean these. The first.
That's what he
That's
just
Wait, did you say the second?
No, he said the first.
So anyways,
You are a retard.
Okay, so here we go. Notice the two distances. R1 is going to be 2 meters, right? And R2 is going to be 9 meters. And our relative intensity is 100 decibels. So what intensity is perceived, if the closer person, whatever. So what intensity is perceived by the referee? So this relative intensity is at 2 meters. So we want to know the relative intensity at 9 meters. Does that make sense? Okay, so we gotta kind of do that thing where we go from B2 to get an I2 so that we can get an I9 to get a B9. And if you'll remember, we said P is IA. And what that means is that IA of 2 is the same as IA of 9. Remember that? Okay. And since A is 4 pi r squared, we can say that I9 is going to be equal to I2 times A2 over A9. Obviously, the 4 pi's are going to cancel, and we get I2 R2 squared over R9 squared. So now we can say, okay, well, what is I2? I2 is going to be 10 to the 100, it's 100 over 10 minus 12. So that's going to be 10 to the minus 2 watts per square meter. And then we're going to multiply that, so it's 10 to the minus 2 watts per square meter times 4 over 81. Which is going to be about 1 over 20, right? Which is 1 over 20 is like 0.05 or something. What? No. Silly boy, that's not the answer. So, so what is 4 divided by 80? Is it like 0.05 about? Okay, so if it's around 0.05, which is 5 times 10 to the minus 2, then our answer for the I9 should be about 5 times 10 to the minus 4 watts per square meter. I plug it into 10 log of 5 times 10 to the minus 4 over 1 times 10 to the minus 12. So we take, this becomes, so in your calculators, do 10 times the log base 10 of, it looks like 5 times 10 to the 8th. So 10 to the log base 10 of 5 times 10 to the 8th, and what do you get? Okay, 86? 87 decibels. 10 to the negative 3? Yeah. 0.01 is 10 to the minus 2. Yeah. So you got the same answer as me.
It's okay, Dave.
Right? Because 0.01, right? It's 1, 2. It's minus 2. Go to the right. Minus 2. Yeah, that is 1 times 10 minus 2.
Oh, that's what you mean.
Because what is 10 to the minus 2 power? 101. Oh, wait, yeah, it's supposed to be 1 times 10 to the minus 2. Actually, what I'm doing, that's actually a good point. It's this. It's not 10. Well, I guess it's the same thing.
Oh, 1 times 10.
Yeah. This is actually 1 times 10. It's like the 10 button on your key, the shift log base 10. It's like the fast way to do it. Okay. Yeah. Okay. Is 1 times 10 to the minus 2 watts per square meter. And then I9 is 5 times 10 to the minus 4 watts per square meter. So 1 over 5 is 0.2, so it's 0.2 times 10 to the 2, or 2 times, sounds like 20? Is that right? So I guess technically I should have said 20 times. Now, if there are 5 horns all at a distance of this from the listener, what would be the perceived intensity? So, remember, we can't multiply perceived intensity. So you can't say 5 times 89 or whatever it was. Okay? You have to multiply 5 times the actual mechanical intensity, which will be the new intensity, the total intensity, will be 5 times the intensity at 9 meters. Okay, and the intensity at 9 meters was 5 times 10 to the minus 4 watts per square meter. So then that's going to give me 25 times 10 to the minus 4 watts per square meter. So now I say relative intensity is 10 log of 25 times 10 to the minus 4 over 1 times 10 to the minus 12. And so and then, of course, here the frequency of waves are perceived differently because of the, so that one I'd say C, wave is spreading out, is called as a result of, so that's going to be A, diffraction, and D, refraction, and B is polarization. And that is how I would go through that. Sorry? I mean, I could have made a mistake, but that's what I'm getting.
Yeah.
Okay. Nope. Yes. Damn it. So you got to hear me swear. That's awesome.
Son of a gun.